Hi everyone, I thought I would do a video on how to do compression articulation armor. Now, I'm not an armoring expert, but there just don't seem to be any videos on how to do it out there at this current time. So, I figured I'd help you all out. This compression articulation armor is the kind of armor you would have seen on examples like Henry VIII's field of cloth of gold armor on the inside of the arms, where there's no chainmail but a heap of plates that overlap, and he can fully flex his arm while wearing it, and it completely covers him with plates as opposed to chainmail, which a lot of other earlier styles of armor used. It was also used in some of the armor in the Elizabethan era, and there are some gorgeous examples out there. So I want to do a little tutorial on how to do that kind of armor to the best of my knowledge. I'm not an expert on armoring. In fact, lately I've been building my armor out of PVC because it's my first suit of armor, but I've been doing a lot of research and I think I've got it sussed out. But I figured I'd share with you so you can at least have the benefit of the information that I have already struggled very hard to get a hold of. First thing is, it's made out of all of these curved pieces of steel. They're pretty easy to do, you just gotta make a template and cut them out. Now I made the template using the curvature from a lame of armor, you know, on a normal piece of armor, on the outside of the elbow. Here's a piece of armor, here's the elbow. That section there, you've got the elbow, which really in a more traditional piece, well, which in a traditional piece would have been dished out heavily. Here it's just flat because this is a piece of PVC armor. This section here, between the bit going up your arm and the elbow that articulates or helps the articulation, I took the curvature of one of these pieces from a different template and used that as the curvature for my template for the compression articulation. So I had a template for that section, or a lame, whatever you want to call it. I used that same curvature on these pieces that are 1 inch wide and however long I needed them. Right, so there's 9 of these pieces, but the middle piece I have seen done in 2 different ways. In one way, which is the way I'm trying now, it is the same curvature on each side coming down to a point, so that there's only going to be 1 pin in this. So it'll be the middle. I'll show you on this cardboard version I made. The middle piece goes like that. Of course that's around the wrong way, so this is the way it would actually be presented to you. That middle piece is the lowest piece and has 2 overlapping. I have also seen it done so that there are 2 and they don't overlap. They just come together and meet in the middle. But I'm giving this version a try to see how it works, because it is shorter and it compresses like that. Now so you've got your piece and it compresses like that. But I'm giving this version where it comes to a finer point to go first. This is my first time building one out of steel. I'm not an expert, but I just want to give you guys a bit of a head start. So I've cut out all of my pieces. This is galvanized steel, which is not really good for making armor if you're going to be heating it, because when you heat up the galvanized steel it releases toxic fumes apparently. But because I am not going to be heating these, and I had a heap of galvanized sheet metal around, I decided to give it a go with this. So what I'm going to need to do is figure out where to put 2 little rivets in here and drill out the holes. Oh, I should probably mention how I made these. I did up my template. I figured out what one of these pieces was going to be like, because they're all meant to be the same, though they didn't all come out the same because of human error. So I traced that out onto the steel and ended up cutting it out with a pair of metal shears, biggest ones I could get down at the hardware store. I tried originally with a hacksaw blade, but it wasn't as good because you can't really turn it quite so quickly. But with the shears, it was an easy matter of just bending the bit that's already cut out of the way, because even though that was going to be another one of these, and I bent it heavily so that I could get the shears in to get that curvature right, I was then able to hammer it out pretty easily. I didn't even need an anvil. Just needed something hard enough and flat. So I was able to change them back to being flat after I bent them to get them out of the way and cut them off. Then once I cut them off, I made sure I smoothed all the edges with a bastard file. This is so that it's not covered in sharp edges or little bits sticking out that could scratch you up and cut you open. So now it's, well, we want it because, well, we want it to be armour. It's meant to protect us, not tear us to pieces. So I smoothed out all the pieces, and now I'm going to hammer them so that they're curved and sliding over each other. Now start with this centerpiece, though it's technically not really a centerpiece, because it doesn't sit in the middle of your elbow, it sits towards the front, so that it doesn't actually have to flex this single piece. Showing it on this. See, if it was in the middle, and you tried to close your arm on it, you would have this big piece of steel running flat through the middle. So it's actually offset, and I've seen them offset below and I've seen them offset above. Not sure how much of a difference that would make, but it's offset. That's why there's 9 pieces like this. I'm putting 5 above it and 5 below, but I need to shape this piece first because this is going to be the lowest piece on the armour. See, every other piece slides over the top of it, like in this cardboard version. So this is going to be the narrowest point. So I need to make sure this is shaped right to fit around my arm and whatever padding I'm going to use, which I probably really would want some kind of padding underneath this. Right, so I've gone and bent them onto shape so that they overlap with and basically all fit over each other. Forgot. Wait, is that right? No. Side for 4, the side for 5. So now I'm going to mark down 1 centimeter from the tip in the middle, put a hole there, and use that. And here we go, the final result. That turned out awesome. Now I will point out one thing. You don't just measure out the holes, put them in, and then assemble it. What you need to do is to work on it and figure out where each hole goes individually. So I started out with the first one, and I put it together, saw where they overlapped, and figured out where I could put a hole. Put that in, and attach the next, and next, and next. And the reason why you do that is mostly because of the distance running across the arm. See, say you put in 1 pin on this side, then you squeeze it together, and you figure out where the pin would go on the other side, so that so that the pieces are as tight together as possible. Though you leave just the tiniest little bit of slack in there. And so I would put in one, go press them together, go over to the other side, find where they overlapped, mark it with a permanent marker. Then I take my nail, or you could also use a hole punch, and I put a little dent in it so that the drill wouldn't just go all over the place and would actually have a hole to start in. Drilled the hole, lined them up again, took my permanent marker, put it through the hole, then took them apart and saw if it had enough room or if that mark could be moved, and lined it up using the hole and the marker. When it was in the right spot, put in the dent, put in another hole, put the screws through, move on to the next. And it has taken quite a long time. I started this I think around 8 o'clock. It's 1:30 in the morning. Actually, I think I might have started a bit before 8. Oh well. It's not a quick project. So now I've got to redesign and remake the entire arm based around this, because this will not fit into the previously made arms. And it is actually so easy. Kind of wishing I'd done everything in steel to begin with, though it is heavier than PVC. Alright, thanks everyone. See you.